Hi, how's it going? I'm Anton Frablewski, and I'm standing in front of an outcrop behind Glendo Dam here in eastern Wyoming, and it's an outcrop of Morrison Formation overlain by Cloverly Formation. It's covered up by some cement in an effort to stop it from eroding. The Cloverly tends to kind of break off in chunks and come down and knock out chunks of the roads. They've got barriers all along it to kind of try to mitigate that. But the interesting thing here is not the erosional power of gravity and coarse grain material, is that we have a succession of Jurassic floodplain and lacustrine deposits. That's those gray and green smectitic chlorite-rich siltstones and claystones. There's maybe some thin limestone beds in there as well. That's the distal expression of the Morrison distributed fluvial system. So during the late Jurassic, the severe mountains out to the west were sourcing a whole bunch of clastic material towards the east. The Western Interior Seaway had withdrawn at this point. The first occurrence of the Western Interior Seaway, the Sundance Sea, had retreated due to tectonic uplift of the ancestral Rockies. And in another video, I showed you an example of that in northern Colorado, where the basal Morrison Formation itself was sitting directly on top of an unconformity on top of older Sundance outcrops, the Pine Butte member aeolian deposits. Well, here, the Morrison is prograded completely. It's done its thing. The dinosaurs have reigned supreme for a couple of million years. At the top of the Morrison, at about 145 million years, though, there's an unconformity. So the Cloverly is about 15 million years younger than the top of the Morrison. All the stuff in between is gone. So we have another unconformity here. And in this case, it's not a section with marine rock sitting on top of non-marine. It's not a section of non-marine sitting on top of marine. It's non-marine and non-marine. So the Cloverly is a thick amalgamated fluvial succession. You can even see some cross-bedding in that. There's these big fluvial channels that have prograded out from the severe. Much higher energy, a lot coarser grain material traveling a lot further into the basin than the Morrison Formation. In the Morrison Formation, the coarse grain material was sort of sequestered more to the west and to the south, as opposed to making it all the way here into Wyoming. So something happened, and the idea is that the severe orogeny really kicked into high gear at some point. So during that uplift of the severe, there was a progradation of a lot of coarse grain material. What happened prior to that to create the unconformity? That's where some of the debate comes in. There's an idea that during periods of quiescence, the basin will rebound, allowing it to erode, and then during progradation of the clastics out from the severe, they kind of overrode that. So are we seeing quiescence where the basin sort of rebounded and you had progradation coming out? Or are we seeing sort of a regional uplift followed by thrusting and immediate progradation? These are some of the things that keep sedimentologists and stratigraphers like me thinking, working, and looking at rocks. As always, I've got a whiteboard cartoon that kind of explains this outcrop in a little bit better detail. So in case you're not looking at the outcrop and thinking, oh, that's obvious, here's my cartoon version of what's happening. So the basal Morrison Formation is depicted in green because it's sort of a chlorite-rich unit, and it's a Jurassic floodplain and lacustrine succession. Lots of big dinosaurs found in there, various trace fossils, cool insects, and things like that. It's about 145 million years old. Then there's an unconformity, missing time of about 15 million years. It's not screamingly obvious in the outcrop. You would not recognize this unconformity without biostratigraphic data, and again, the regional context. And then the Cloverly Formation, which is Cretaceous and about 130 million years, made up of these amalgamated fluvial sand bodies sitting directly on top of the Morrison. So just like the outcrop I showed you in northern Colorado, the unconformity here is pretty cryptic. You might not know it's there. If you were only looking at the outcrop with no additional background data, no context, you might miss it. So the three take-home points here again are: we have a Jurassic floodplain, a Cretaceous amalgamated fluvial channel, and that really cryptic unconformity in between that you really need to have good biostratigraphic or chronostratigraphic data to recognize. So once again, if you're a geo or a geoscientist, step away from your computer, stop playing with Python, stop looking at Excel, get out, look at some rocks, get dirty. You'll be happy you did. Thanks for watching.